So we're talking about definite integrals. We already did look at the fundamental theorem of calculus, all right? And remember, a definite integral gives us the area bound by a curve in the x-axis, okay, between two x values, all right? So here you can see if capital F of x is the antiderivative of f of x, where f of x is continuous on an interval where x is between a and b, then the definite integral of f of x on this interval is the integral from a to b of f of x dx, and that equals capital F of b minus capital F of a. So we saw that that was our fundamental theorem of calculus. And again, just to illustrate this, you're going to give me a... There we go. Let's try that again. There we go. We have our function f of x, okay? Here's our interval. Here's a. Here's b. Our function does have to be continuous over that whole thing. If you have an asymptote in the middle, you cannot find the area. All right. If you have an undefined point, you cannot find the area. All right. So, but the integral allows us to find this area here by doing f of b minus capital F of a. All right, so you have to find that antiderivative and then evaluate it for the two ends of your interval and subtract. Okay? So we've already done some of that. What I want to look at, though, is how we would use the calculator to do this, to check our answer, and then we'll do a little bit of practice with it. Okay? So, let's, first of all, take a look at this integral, okay? We have the integral from 2 to 5 of x times e to the x dx, okay? Now, the challenge with this one is the fact that x times e to the x dx cannot be done using any of our rules that we've learned so far. Even the u substitution, if you looked at e to the x as your u, the derivative of x is 1 dx, not x dx. So we can't even use u substitution for this one. Okay? We would have to use some kind of a method using sums or something like that. Okay? So, what do we do here? Well, for this, in our purposes, we're just going to use the calculator. All right, so first of all, for the TI-83 or 84, if you hit the math button, if you have the TI-83 or 84, get that out, okay? And let's actually practice doing this on the calculator.
Not the Inspire.
Okay, we'll do the Inspire next, okay? But if you hit the math button, which is a couple below the, or it's just below the alpha button, okay? Hit the math button. Number 9 is this fn int. That's the integral of a function, okay? Now, some, depending on what kind of firmware you have installed on your calculator, some of these are really nice in that they give you kind of a template, and they give you a little box here, a box here, a box here, and then a box with an X after it, or sorry, a D with a box after it, okay? And all you have to do is fill in the blanks, all right? You would put the 2 in here, the 5 in here, you would put your x times e to the x power in here, and you need to tell it what variable to different or to integrate with respect to. So you would put an x in here. And you plug it in, and you should get 586.2635803. Okay? If it doesn't give you that nice template, it'll show you this right here. Okay?
So what are the exact buttons on the Inspire so I can write it down?
We'll get to we're not doing the Inspire yet. We'll get to that. So here, if your firmware just gives you this, you need to type in the function, okay? In the parentheses, you have your function, so you need to put in whatever that is. After that, you'll need to put in x, because that's what you're finding the integral with respect to. And then you put your lower boundary, in this case 2, call that LB for lower bound, and then your upper boundary 5 in this case after that. Okay? And you just hit enter, and you've got your integral. Okay? I believe mine just gives this here, but you can see it. Math, number 9 is fn int. Okay? I would type it in with the x's. X times e to the x, comma, x, because that's what I'm taking the integral with respect to, comma 2, comma 5, close my parentheses, and there we have it. Okay? Everyone understand that?
Can you show me one more time you get to F?
Hit the math button right here, and then all the way down at number 9.
Okay.
You can just hit the number 9 and it'll put it there for you. Okay? Alright, so that's on the 84 or the 83. Okay? That's what you plug in. Now, for the Nspire, it's actually a little easier. There's a button to the right of the number 9. Okay? And that brings up a number of different templates. Okay? Do you have your calculator with you?
No, I'm going to write down the steps because it doesn't work.
Okay. So, yeah, right to the right of the number 9 is a little thing. It has a box with a couple little boxes above and below. That brings up a number of different templates. And you can just use the arrow keys to go find the one for the integral. Okay? And then once you do that, you can simply type in, it's just like this was. It gives you a template just like the newer 84s do.
Yeah.
Okay?
And you plug in.
And you just plug in those values.
Got the same answer.
Good. Okay? So now you can check, you can always check your answers to see if you got it correct on your definite integrals. Don't just rely on that, because you will potentially have definite integrals you have to find by hand on a non-calculator part. Okay? But this is a good way to check. And this is a thing, if you get one of these on a calculator part of the exam, set up the integral you're trying to find, and then you can just plug it in. Okay? And write down the answer. Okay? So, alright, so let's try a couple of these. Okay? And this will help us kind of refresh our memories as to how to do some of these problems. That'll give you the rest of the time to practice. Okay? So first of all here, it says, show that 4x plus 1 over x minus 1 may be written in the form 4 plus 5 over x minus 1. Okay? So let's think about this. If I want to split this fraction into two separate ones, this is more of an algebra problem than it is a calculus problem at first. Okay? But here's what we have. We have, if I want to end up with 4, that means I needed to have a 4 times x minus 1 over an x minus 1, right? That's the only way I could have gotten just a 4.
Wouldn't it be 4 plus times x plus 1? The top is 4x plus 1.
Well, here's the thing. I want it to end up equaling 4x plus 1. So really all I need to do is make sure that this comes out to a plus 1, which if I distributed that again, I'd get 4x minus 4 plus the 5 over x minus 1, right?
Yeah.
And negative 4 plus 5 does give me a plus 1, like I'm supposed to.
Okay.
Okay? So, alright, now that's significant because now, if I am able to rewrite this as this, then when I'm asked to find the integral, I can do the integral from 3 to 5 of 4 plus 5 over x minus 1 dx, right? So now we can integrate. We have here the integral of 4, which is 4x, and then 5 over x minus 1, okay? Well, that's just going to be a plus 5 times whatever the integral of 1 over x minus 1 is, right? What's the integral of 1 over x minus 1? Natural log of absolute value of x minus 1. Good. Times 1 over the derivative of x minus 1, which is just 1, right? Okay, so that's it. Right? We're a little rusty after a week off. That's okay, that's why we're doing this. Alright, so now I need to evaluate this from 3 to 5. Okay? So, 4 times 5 is 20. Plus 5 times the natural log of 5 minus 1. So that's the natural log of 4, right? Okay? And then I have minus the integral evaluated at 3. So that's going to be 12 plus 5 times ln of 2. Okay? So, I'm going to distribute the negative and rearrange a little bit here. I have 20 minus 12, which is 8, plus 5 ln of 4 minus 5 ln of 2. What can I do when I'm subtracting logs?
Take out the 5 and just subtract the
Okay, good.
It's just natural of 2.
How do I know it's natural log of 2?
4 minus 2.
We can't just do the 4 minus 2. When you're subtracting logarithms, think about your laws of logarithms.
Oh, it's dividing 4 over 2.
Yeah. You'd end up with the same number, but you want to use the right method. So we'd have 8 plus 5 times the ln of 4 over 2. So 8 plus 5 ln of 2. which is what we wanted. Okay? So, some interesting things here, okay?
They don't want you to simplify that down. You can just leave it natural log of 2.
Yeah, you can't, yeah, that's an exact value, so rather than do anything more, we'll just leave it like that. Okay? Okay, so here's a couple others. These ones, you can evaluate the functions. They're trying to get you into the concept that an integral gives you area. So if I'm integrating from 0 to 3 on 11a, here's my function from 0 to 3 is going to be this area right here, right? Well, that's like a little rectangle. Well, no, that's like a trapezoid with another trapezoid on top of it, right? So you can find the area using geometry, but there again, we're trying to get into the idea that area between the x-axis and the function is the integral. What about the integral from 3 to 7? What do I know about that one for b?
Negative.
It's negative. There we go. Okay? It's negative because it's below the x-axis. Okay? If I'm going all the way from 0 to 7, what am I going to have to do?
Subtract what you found on the top from the bottom.
Yeah, this minus this will give you a net area, you could call it. Alright?
Would there ever be a problem where they ask you simply what is the area of the shapes, so that you don't have to subtract it if it's on the bottom?
Well, and here's the thing. If we will actually look at ones like that, where we're finding area, you're going to have to find like where the 0 would be. In fact, do we even have some here? I don't remember. No. There will be some in the future where you have to find the 0 and you're going to have to divide up the interval from 0 to 3 and then from 3 to 7 and use the absolute value of this area to find the total area bound rather than a net area. Okay? So some of these will help you kind of refresh your memory on the rules for logarithms. Others, like these, are getting you used to dealing with the fact that we're talking about areas, okay? And then some notation, writing these all as one integral. Those are relatively simple, but it's a good exercise to work with here. Here we're working with different intervals and things. Look carefully at the intervals that we're integrating over on 14, okay? And then some other, just like some problem solving with these, using some given information, and what you know about integrals, okay? So, some good practice here. I'm going to let you guys use the rest of the time for that.